That's true.
All right, so while you guys are enjoying your lunch, my friend John here has agreed to come and talk to you about the cool stuff he does, not only with Sparkfun at AVC, which some of you may have seen when you were there, but also his space job and his hobbies, which are pretty remarkable. So I'll let you take it away.
All right. Hey guys, my name's John, and this is a cool picture of Earth. Cool. 4 minutes later, this is the standard background for my day job, my real job. So, really boring slide, but this was reserved. Moved it after Dave. Got an undergrad and master's degree in mechanical engineering. But what I want to talk to you guys about is some of the projects that I've done. I got to be making basically Formula SAE is a race car competition done at the college level where you build from scratch a race car. It's like a glorified go-kart or a small race car, a motorcycle engine, 100 horsepower, 0 to 60 in 3.5 seconds, kinds of stuff, so it's pretty serious. AVC, this is super blinky, I'll tell you a little bit more about her later, and I'll tell you about what I do now. So how did I know Dave? This is a picture of us on the top of, I believe, Snowbird on our first big ski trip together, and we do these kind of annually or so, but now we both live in Denver, which is even better, so it's 16. Yeah, so having fun's important too. So this, so basically, I show up, I'm an undergrad, freshman, don't know anybody, don't have any projects, and lots of spare time because classes are not when you're in college. So, looking for something to do and stumble into these guys. This is the Formula SAE lab. As I first saw it on my first night there, this is this welding table they just got. That's what we're going to build the car on. It's a nice flat surface. And the months before, they've been working on drawings for the chassis, so it's brand new. The bottom layer of the chassis going together. So one of the problems we had is nobody knew how to weld. And welding holds the chassis together, so that's pretty neat. So we had a staff guy, Dave Conger. He would do our tacking and our welding, but only in his spare time because he had another 40-hour real job. So he would do some of it, but that just wasn't working out. So I just went to the library and got a book, read it, and took welders back in the corner there, and he said, "Have at it." So fire it up, and you start blasting some holes in metal, and that didn't work, and figure out how to turn this knob up, that one down, and all of a sudden I know how to TIG weld. And then I was basically the primary welder on the car. So that's a younger version of me in the back, and this is the chassis a little bit further along. See all the little clamps and stuff holding it together. It's just tacked in place. One of the really crazy things that happens with welding is when you weld it, it cools, it shrinks, and then it totally twists and pretzels on itself. So you have to hold it in really rigidly until it's all completely welded. So a little later, the engine's in the back, looking a little more like a car, but still missing a lot of pieces. Fun picture of me welding. So some of the problem with welding a picture like this is this one looks pretty easy. I can mostly see what I'm doing. Got some rests to put my hands on, that helps a lot. This one's a little harder. It's kind of reaching way down in there. I can't really see what I'm doing, so you just kind of go after it over there. And then this one is kind of a ninja level weld that is really annoying. So I turned to the picture. So big thing about welding is keep your face down in there and seeing what you're doing. And I don't think our staff member would have gotten into this position to do this well before us. You have a question?
You ever let yourself on fire trying to weld?
Ooh, fires, yes. So yeah, welding's really hot. The cool of metal is like 3,000 degrees Fahrenheit or something. So it's, you burn yourself. I definitely kind of burned my arms a little bit with hot metal. Trying to keep, so it's really important, the whole welding table is made out of steel and so it's stuff that won't burn. You forget, so you like set like the torch down or something down that's still going red hot on a piece of paper and it kind of burns a little bit. So you do have to be really careful, but you didn't really have to make sure to attach it. And interrupt me if you have any questions. So here's a CNC milling machine. We're making a This was not yet me doing the CNC milling, this was a skill I learned later. There's a lot of machine work that we had to do. Here's another one in the front of the car. So a little bit about this guy. So this is a pretty complicated assembly, the front wheel assembly. So it's the hub that spins, the brake rotor to stop, the caliper that squeezes on the rotor to stop. So it has to spin. It's important that it spins because the wheels have to spin for you to go forward. Well, when we first put it on, this is after like a month and a half of CAD modeling and finding the parts and making it all fit and making this really expensive custom part. We put it together and the hub hit the brake caliper, so it wouldn't turn. So we had to figure out spacers and things to find a solution to get it to go. So that was one where, I mean, you can do all the analysis in the world, but you still have to put the thing together and make sure you can screw it up. One of the other fun pictures, I don't think I have a better picture of it, is the steering rack. So when you turn the wheel left, or turn the wheel right, the steering rack moves. But one of the things you forget to do in your head is, does it turn the wheels left or does it turn the wheels right? So one of the things we actually, for real, screwed up on this car is we turn the wheels left, turn the wheel left and the wheel went right. The wheels went right, which would have made it really hard to drive.
That would have been the scariest vehicle.
Yeah, so that would have been okay. We had to then flip, and it was all welded in, ready to drive. And we had to cut the mounts off and flip it upside down. So yeah, the simple things are the ones that you tend to screw up. So this is the back of the car, looking like a mess. Wiring was a fun job. So another kind of fun fitment problem is the differential goes in the middle of the back tire goes over here into the suspension mounts, and trying to see it here, it's a little tough to see. But one of the things that we didn't consider until after it was all built in together was the drive shaft goes in the middle, right off the wheel. And the guy that designed the suspension also put the suspension push rod right in the middle. So those are both necessary components to make, so one holds up the car, one makes the car go, and they wanted to occupy the same exact space. So we had to come up with a creative answer where we actually made the push rod go around the drive shaft. So this is like, nobody's ever done something this stupid before on a race car, except for us, because we rebuilt it and had to figure it out. So that was a quick on our feet thinking, creative answer to get it rolling, get it outside. Then we had to paint it. I didn't know much about painting, but that's me actually shooting the paint. And all shiny afterwards, and then we just the crap out of it because it wasn't built yet, so we were still drilling holes on body panels and things. So this is the best chassis I've ever looked. Right out of the gate. And there it is on its wheels, and this is this was 2 years, so basically 15 months, start to end. 8 students put together a car from scratch, and mostly didn't know what they were doing. So this was a really cool experience, and I could go on and on about how horrible this car is because we learned so much. Like the steering wheel, you can actually see it here, is actually kind of tucked into the hoop, which looks really cool in the CAD model, but then when you actually sit in it, your wrists hit the roll hoop. You can't steer the car very well. The rack was too slow, so you had to turn the wheel a lot back and forth to get through tight corners, and it didn't work very well. It overheated, it didn't start. The exhaust was too loud, but then also didn't flow enough. So it ran really well. It was just, there's so many things that you learn. Yeah.
Did it go fast?
It went really fast, actually. So all those problems aside, it still did 0 to 60 in 4 seconds. So, yeah.
Can I ask a super tough question? How fast would it have gone if you made it like really well, like you guys had known what you were doing beforehand?
So the traction with the rear tires is the problem. So everybody can kind of accelerate and straight line pretty quickly. That was after we tuned down a little better, but the fast ones are closer to 3 seconds, 0 to 60. You can do about 1.5 G lateral corner.
That's rear wheel drive, right?
Rear wheel drive, correct. There was a few all-wheel drive entries, but this one's rear. Typical race car is mid-engine rear drive.
So this is like a competition?
Yes. So, and this is still going on today. So there's about 150 teams in the U.S. and another 50 or so around the world.
I know what I'm doing in college.
Yes, and that's part of the reason I'm showing this to you You guys gotta look through this, or something like this, when you get to school. Yeah?
You guys place?
So this year we were about bottom middle of the pack because we finished all the events. You lose a lot of points if you don't finish all the events. So we finished all the events not well, but we were rookie of the year because we finished all the events. So we were the top scoring rookie team. And there's a huge difference. I've shown you some pictures of like what the top cars do because they look like real race cars. And these are teams that are just refining, they're re-engineering this piece or that piece. And
They've
bigger
been at it
teams.
for years and are just tweaking it to make it better.
Yeah, they have full aero packages, they have turbochargers, it's unbelievable. Guys are not
interesting on it, see what happens.
Yeah.
You say this is your friend?
Yeah, sure.
Want to do it?
So then the cool part about this is you actually get to drive the thing. So there's no professional drivers, it's just the students. So here's my buddy in the car during one of the test days and experiencing some of the ergonomic problems. He's our tallest driver, you can see where his knees are and the hand problem, the shoulders are too tight, and it's just, you design it in CAD, but you really need to go back and make sure it actually works. And here's it driving off with the competition.
Did you drive it? You drove it?
I drove it, yeah, I actually drove it in the competition. I spun it the first and only time because it was actually really hard to get through a corner quickly. But I spun it around and hit a bump and just looped it. And our team was so tired that nobody actually saw me do it. So I talked to other teams that saw me do it just to make sure I wasn't making it up because I was in the car when it happened. But my whole team was just like, is it gonna finish? I don't know.
We'll gotta keep it.
The school does. So this one actually, we drove it a bunch after the competition, but parted it out to build the next car. Pictures of the second car. So yeah, like this moment, it driving away to go off to the endurance event at the competition was just like, holy crap, we made it. It doesn't even really matter what happens now because it's working. It's a complete thing. We had a deadline, it had to work, and it worked. So that's what it's all about, these projects, getting to the end and finishing and actually working. Because there's 100 things that could have broke or gone wrong at this point, and we wouldn't have been able to compete. And that's the key, is it actually getting out on the track. Here's a picture of me looking awfully cool sitting in the cockpit. So this is actually onto the second car in the test days. So it's a whole new car, same process over again. We cut about 150 pounds out of the car, so from 650 down to just about 500. It was way quicker, way better ergonomics. We learned so much, and this was, at this test day, we were a second and a half on a 60-second lap slower than the top shoot team that showed up with us. So we went from being 15 seconds behind on a minute lap to a second and a half behind. So all those little things add up, and you get pretty close. Yeah,
So you're about 500 pounds. How much horsepower do you have?
about 80.
80 horsepower.
Yeah, it's
300
good. And that's, yeah, and that's without the driver. So, driver.
Yeah, that's just the driver. That makes sense.
So if you see me standing in the driver's seat there, this is me TIG welding in the trailer with the driver's seat on. So that's the shift handle that broke. So we brought a generator and we bring all our tools. We basically bring the whole shop to the test day because you never know what's going to break or what you're going to have to fix. So we're disassembling, welding on the car, putting it back together, getting it back out on the track. And this is 100 miles from our own shop. So this is just figure it out, get it to go. This was one of the more memorable failures. So this is the front wheel, and this is the hub, and there's some welds here that I did, and the bearings are in there. So you can kind of see a little bit, there's some cracks here. So it was on the course, there was a front wheel wobble, so we brought it in, took a look at it, saw that wasn't a very good sign. So this is what happened. So that's the wheel with part of the hub, and that's the rest of the hub. But all of the welds proceeded to crack, and this was an enormous lesson in fatigue life and weld strength and alloy selection. I mean, I could go on and on about it, but to not bore you with the details, I screwed up about 3 or 4 different things, and it led to this failure. I didn't know what I was doing, basically. So So from this test day to the next test day, I opened up 17 books and learned about all this and talked to some welding experts. Designed a new one, did a new CAD model, machined the parts, welded it, put it on the car in 1 week. I went to my classes too. And that's the new hub with the fixed handstand.
Was that the same wheel as last year?
Same wheels, yeah, we didn't change the wheels. A lot of the parts were common, but we changed them initiatives. So, yeah, that was a sad day. We didn't continue after this one. We talked about trying to re-weld it back together, but it just wasn't the way. Yeah, that was a sad one. Yeah, so I think this is a video clip of it buzzing around. I don't have very many videos because we didn't have cameras running. So this is just some braking tests we were doing, but you kind of get a feel for how quick the car is. And basically the competition is doing this 3 pounds. And it's really cool when the car is driving it. I won't bore you with the details. We had another one on this test day. So this is basically a belt crank and it rotates about this axis. And there's some welds down in here. The whole thing just like canted over, cracked off. And it was just another design problem. Because a lot of it, you're just thinking on your feet, like, yeah, that looks about right. Which is a really good skill to have, but not necessarily if you're like designing a space shuttle or something. You can't learn by having it fail, so you have to do it by analysis. So it was cool because we went back, did some analysis, did some rework, and then did break after that. This is us, took a picture of me in the car in the trailer, give you a feel of what it's like showing up to competition. Basically packed the whole shop in the car, drive the machine. That's a picture of the second car, which looks a lot better. So, anybody have any other questions about the car? Yeah.
So you joined this club knowing absolutely nothing, and you decided to build a car.
Yeah, I knew very little. I did a few autocrosses. So this is SCCA runs autocrosses, which is a big event where people show up and drive their cars around cones in the parking lot. So I'd done that a few times at that point, but I didn't know anything about driving. I certainly didn't know anything about building cars or race cars or anything like this. So it was just like learn as you go on your feet. And this was probably more valuable than all the classes I took in college. Not that they're not valuable, but they make it mean something. Because like all the things that broke, that's when, so you're like learning in a book about material science and you're like, I don't know, there's graphs, yeah, okay, it's probably gonna break, but it doesn't really mean anything until your wheel falls off the car. When your wheel falls off the car, you know you have a problem. So yeah, there was something else going through this.
Are those street legal?
No. There's actually a team that made their street legal. One of the problems is you need bumpers that are like yay high, you need headlights that are way up here. It's not,
And tail lights.
Yeah,
and mirrors.
it's not what you want to be driving around on the street. There's 1 inch of ground clearance on this car, right? So, pothole this big, speed bumps, yeah, it doesn't really make it over much.
What are the rules for like the body regulations? Like, are you allowed to enclose the wheel hubs?
So it's actually really cool. It's very open, so they're very vague about what it has to be. It does have to be open wheel, so you're not allowed to have like body panels. But it actually goes to kind of simplify the car, and everybody's showing up with more or less the same thing. So it's single seat, open wheel. It doesn't say where you have to put the engine. It doesn't say which wheels you have to drive, or much of anything about how you design the car. But then you just kind of look at how everybody else solved the problem, and that's a really good starting point. You don't want to go do something that's totally off in left field.
One thing that occurred to me was create a enclosed cockpit. It makes it a little bit more streamlined, say for.
Yeah, so there's some aerodynamic advantages. Closed wheel cars are faster than open wheel cars.
Yeah.
So even though F1 is like one of the fastest series, it's open wheel. They'd be faster if they were allowed to put.
Yeah, there was a thing where I asked the Red Bull team designer, what car would you make if you could ignore all the rules and regulations? And and he came up with a design. You should check. It's called the Red Bull X 2010.
I've seen pictures. It's a lot like an LMP1 car. LMP1 is the series that's basically do whatever you want, go medium, go fast. Sounds fun.
What about, were there any restrictions on performance parts?
Not so much. One of the big restrictions that prevented you from spending a ton of money on expensive race parts is you weren't supposed to spend more than $25,000 on parts, which sounds like a lot, but the bike engine's a few thousand, the shocks are 500 or 1,000 a piece, the wheels, tires are expensive, so it starts to add up. So basically, you kind of have to spend 10 to 15 just on parts, and you can be a little creative with the rest. By making stuff, you can say it was a lot cheaper because you didn't have to count your labor and design and R&D, which is really expensive, but it teaches you a lot, and that's the point. They really want you to basically be making this stuff with your hands. It's competition, and it's so valuable to have done.
Do you get anything if you win?
You do. You get there's some big cash prize, like $5,000 or $4,000, I think, which is basically just the fun with that configured car. And bragging rights mostly, because you took this big competition. There's 140 schools around the country that show up, and I think there was 12 international teams when I went. And it means a lot to go back and say, your resume, you won the Formula SAE competition, basically any automaker being really good shape if you're on that team. So it's a big deal to be on a successful team. Okay, so I want to tell you a little bit about AVC. This is cool. This is, so I did that racing thing, and then now I've moved out here, and I've been here for years, and I had an itch to do something. So this is my answer. I got together with a buddy of mine who was on the first car racing team, and we built this. So a little background, one of the things I did in grad school was work a lot with GPS and sensor integration and things. So this car basically runs off of a GPS, accelerometers, and gyros, drives around basically with its eyes closed and navigate around the course. So there's no obstacle detection. We just program the path with GPS, and it can stay within about a meter or so, a meter or two, typically about a meter of the course that we planned. So it's really hard. To give you a feel, there's some obstacles, which I don't have pictures of those. There's a hoop that if you go through, you get bonus points. There's a ramp, if you go over, you get bonus points. But those are really hard. They're very careful about how big they are. So it's small enough that it's really hard to hit with GPS alone. So you really need to have some sort of visual sensor or something to kind of find an obstacle and go over it. So that's not something we did. We just made it a simple fast-traveling robot, and it went really fast. It was our fun part. So it was kind of cool just testing and tuning the controller and making it drive around the empty parking lot pretty quickly. So
you know the track before you go there?
what's that?
You know the track before you go there?
Yeah, they have a picture, they give you a satellite image of where all this stuff is. And yeah, so you kind of know what to expect. You still need to go and run it on the actual course because there's a lot of problems with just, like if you've never tested it, it might be offset or it might do something a little differently. So they'd let you test it on the course before the day of. Okay, so this is cool. So I can show you this video. I should have talked while this was running a little bit. But this is us setting up at the starting line there. So basically there's a bunch of heats, you go 5 at a time, and you blast around the course. And it's kind of cool because then you start having some collisions on course. So it makes it pretty exciting for the crowd. Yeah, so I can tell you a little bit about what's happening. So right now it actually thinks it's driving autonomously. Because, so, I don't want to ruin it for you because there's a little bit of a lesson learned here. But, so this is not exactly the way we typically did it. Typically you just flip it into autonomous and go. But because you have to sit here and you have to turn the switch to make it go, we've never done it quite like this before. So we're kind of waiting around, we're waiting to get everybody ready on course, so this is way longer than we'd ever let it sit. Thinking it's running autonomously, and it's not. So we have no idea what the software is doing right now. It thinks its position is kind of bouncing all over the place, even though the GPS knows something. It thinks it's driving, so it thinks it's going forward.
Be mindful that there could be someone sitting behind you on the bleachers, so just gotta be mindful that could be happening. Maybe sit down. low as those on the front rows of bleachers, so you can all see everything. We don't have the greatest grandstand here for bleachers, but we do our best. Oh man, I'm out of the game quick.
So that yellow pole at the bottom of it has a bucket, and they fill it with concrete so it doesn't fall over. And actually, if you grab the top of the pole, it's like a little bit tough to push it over. But we did 2 inches from the bottom. So I have another view. That's a pretty nice one.
Well, couldn't you have left it off until they press start? Or is it start?
Yeah, so that's what we screwed up. So then he climbed up the bale of hay and proceeded to spin his tires and throw in his front tires to the bumper. So there's where's the presentation?
The close on that?
It's gone.
Yeah. Not that one, that's the one. No, that's not what you wanted. Right click, open with.
Oh,
Yeah, the code card window.
That's probably this one.
That's the one.
So we've got a picture of
Put
the
your comment in.
aftermath here. So that front bumper is supposed to prevent it from, when it hits an obstacle, kind of deflect it rather than going straight. But we hit it right on the nose. So had we hit the edge of the bucket, it would have been fine, but we went straight into it. So this is bent up 30 degrees. It's wrecked the one tire. So without that, the car probably would have been pieces because it crashed at 20 miles an hour into that concrete bucket. Scale that up, that's like a brick wall through this thing. So, so basically what happened is, what I described is, it was sitting there, thinking it was driving around, and it actually flipped off the first 2 waypoints. So it's supposed to go over here, went to the 3rd waypoint, which was through the yellow bucket, unfortunately. So the lesson is, you gotta make sure you do it the same way. On complicated systems, you never really know what you can screw up if you do something just a little bit differently. So here's a really cool video or image sequence. At the end is this little 2 or 3 inch ramp. You can see the catch like about a foot in there. And it's like, I don't know, 15 feet or something that we jumped. So it was pretty quick. It was fun. And the 2nd and 3rd lap, we were about 30-second laps and got around the course without doing anything. So we were like 4th place out of 50 or 60 teams. We would have done a little better if that didn't happen on the first run, obviously. But anyways, it's cool. Is there any questions about that? Yeah.
I had 2 questions.
Yeah.
How many sensors did you have? Did you just go off of GPS, or did you have visual odometry, or what?
No visual, no odometry. It was just a GPS, a gyro, a magnetometer, and accelerometer. So it's just pure close your eyes and drive around with an IP and GPS.
Do you have a column filter on there?
It's the one that's in RG Pilot 2.6.
Okay.
So I don't know much about the details of the implementation, but it's that I know you can kind of tune how much is predetermined by the vehicle model versus the sensors. So it does a little bit of mixing, and I don't know much about how it works. I do know, so in grad school I did a bunch more with this. We actually made a lawnmower that had a very expensive $25,000 GPS system. But more or less the same idea here, but we have some fancier sensors. So this can keep track of where it's at from like a meter or 2. That could do 2 centimeter accuracy. So this is it's a 5 centimeter reel, and it would run over the same track over and over again in grass, running around in circles. So it was really, really cool to see what you can do with it. And it's a lawnmower. But it was the same thing, it was for a competition, and it was basically some technology demonstration. But it was pretty freaking cool. So this was what can you do with quite a bit less money.
This is the one what do you do with parts?
Yeah. So I'll tell you a little bit what I do now. So mostly I just wanted to focus on what got me here, but now I do something really cool. I work at University of Colorado in a lab that helps scientists fly their experiments in space. So this is me just in June. This is our incubator. The samples are loaded in a temperature-controlled line there, and that's just before turnover. 12 hours later, that box is behind the little magic door right about there, and that's 200 feet tall, loaded, well, not loaded with fuel yet, but this is just hours before fuel loading, just before launch. So this is so basically what we do is it gets ISS and astronauts run the experiment. So this is our friend running the experiment on orbit. And there's all sorts of fun complications. It's the same thing as what I said before, but now it's dealing with microgravity, dealing with fluids, keeping it contained, keeping the astronauts safe. And same thing, I didn't know much about it when I started, but I've been doing it for 3 years. It's pretty damn cool. So, and here's a picture of me standing next to the last space shuttle just after it landed. This is just 6 hours after touchdown. So one of the perks of having a cool job is getting to see cool stuff. So my advice is go do something cool, go get after something that you think is really exciting, because that's how you get to see cool stuff like this. So that's all I have. Does anybody?
So, you know, the nose, like right below the window, is that like the door?
This guy?
No, above.
This?
Is that, yeah, is it like
Yeah,
a door or is it
that's-
a meter hit it?
No, it's not a meteor. That's the side hatch. That's the one that they use in and out, both when it's vertical and horizontal. So that's what the crew goes through. The cockpit's up here, and the mid deck is down here. So that's where 4 of the crew members sit down here, 3 sit up there. Our payloads, there's a back wall and front wall filled with science equipment at the bottom. And that's where they loaded. I never got to go in. I never loaded in. I got to see some cool pictures. No. Yeah, a big hole in this vehicle. I mean, I don't know if you know much about it, the Columbia disaster, but basically there's a hole in the wing right here. Some of the foam from the external tank cracked the leading edge of the wing, and that led to catastrophic failure on re-entry. So the shape and the structural integrity of the outside of the vehicle is very, very important. And at this point, they actually do an inspection on orbit. They take the arm and take microscopy pictures of the whole vehicle and have people on the ground analyze it to make sure that they're, and they have a bunch of methods to repair things that can be damaged on orbit. Questions? Yes?
What was the most important thing you did in order to get your first job?
Well, it's a lot of things that added up, but things like the SAE card, that experience was, I mean, there's just so many things that you can't even really put into words, like working with people, working on a team, real money, real deadlines, and that kind of project is so valuable, and that kind of experience is so valuable in real world engineering projects. So doing that kind of thing is probably the single most important thing that got me my first job.
Cool.
Yeah. Get your hands dirty. Don't be afraid to like take something apart. No, don't go take your $1 million thing that your boss doesn't want you touching apart, because that's bad. You can do it earlier. So the stuff you're doing now, like learn how to solder, learn how to drill holes and machine things, and whatever you can, and the opportunities that you have to do it, because those skills going forward make you a really practical engineer, where you can ask questions and maybe, or see things that other people don't see. It's really important. So you want to build on that experience.
Any other questions?
Sorry, I went way too long.
No, that's good.
Have you been on that one thing that goes 0 G?
Oh, the airplane? No, I'm actually working on trying to in the next year. I might get an opportunity to. May or may not happen. They're expensive flights, so it's, I don't know, it's thousands of dollars per seat basically. You get 30 parabolas, they're 30 seconds a piece. We get to float around. Some of the students that I work with have done experiments on those, and some of the other engineers that have been around longer have done it. So yeah, you can get about 30 seconds of microgravity. There's no way to get any longer than that within the confines of the bird. go into space. That's the whole point. It's like microgravity environment. You can do it for indefinitely. So all the experiments that you do are to get to the microgravity.
Anything else? All right.